What is up, Algebra 2 students? This is lesson 25. And our objective for today is kind of three parts. How do you, 1, factor out a monomial, 2, reduce fractions, and your book calls this canceling, but we won't do that, and C, solve triangles with parallel lines. So we're kind of doing, I said C instead of 3. So we're kind of doing three parts. We're going to start right here with factoring out monomials. Before we do that, I guess, we need to talk about the distributive property. Remember, on distributive property, you would take this piece that's out here and multiply it by each one of the inside pieces. That's how we got this right here. So notice this piece, the 3xy squared from here, is now multiplying by each piece inside. So it's right here, it's right here, it's right here. It didn't multiply, it just got distributed. And then if you simplify this down, the 3 times 2 is 6. You got an x and an x squared, x cubed, and then a y squared. So this would simplify down to this, but you could see the different pieces of it here as it was multiplied in. So whenever we're given the instructions to factor something, it means we're going to undo the distributive property. So that brings us to our first example where it says factor. Now for me, the easiest way to factor, and the more practice you get, the quicker you'll be able to do this, and maybe you won't have to write out this step. But for now, we're going to write everything in its prime factorization. So this first term right here, I'm going to write in red. 4 is 2 times 2. X squared is x times x. And then I have a y. Then subtract. Now I'm going to use blue to represent that. What doesn't simplify down any? 2xy. And then I'm going to use green to represent this last part. 10 is 2 times 5 times x times y times y. So to find the least, to factor this, I want to find the parts that all three pieces, the red, the green, and the blue, all have in common. So I'm just going to go through and highlight these with yellow. Pieces have in common. Well, see, all three of them have a 2. I'm noticing all three of them have an x, and all three of them have a y. And looking, that took everything there from that middle one, so that's all the pieces that we have the same. So we're going to kind of undo what we did up here. This got multiplied in. Now we're given this, and we're trying to pull the same thing out. So I'm going to write that 2xy, or 2 times x times y. I'm going to open parentheses. And what is left over from this one? From the red? Well, I have a 2 and an x. So then I'm going to write 2x. What do I have left over from this middle term? Well, nothing, but whenever I distribute this back in, I'm going to have to back to that term somehow. So then I'm going to have to say just minus 1, because 1 times that 2xy will give you 2xy. And then plus what's left in the green one? Well, a 5 and a y. 5 and a y is what's left over. That means to do that. So this would be 5 plus y. And there we have factored that. Let's try one more. Again, we're going to see if we can factor this all out. This first piece here is going to be 8. So this is going to be 2 times 2 times 2 times m times m times x times 1, 2, 3, 4, 5. This middle term here we'll do in yellow, plus 2 times 3 times m times m times m times x times y. So let's just look through. I'm going to highlight in black this time. See what they all have in common. Oh, and I did not finish this out, sorry. Last one we'll do in blue, minus 2 times x times y times m times m. Now we're going to highlight in black things they have in common. So they all three have 2's in common. Looks like they all have a couple m's. 1, 2 here, 1, 2, 1, 2. They all have an x, 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 x. And they all have a y, y, a y, and a y. So we're going to look through and write down the things that they have in common. 2m squared xy. It's 2m squared xy. And then I'm multiplying it by what's left of this yellow one. 3mx. Just kidding. What's left of the red is going to come here. 2 times 2 is 4. Y to the 4th power. Now let's write it in yellow. What's left over from the yellow one? 3mx. 3mx. And then the last one is going to be blue. So minus, and notice I used everything from the blue. So I'm just going to have a 1 go there to hold its place value. Alright, so that's factoring. Now, before we start reducing, we need to think a little bit here. Why is this true? Whenever I say 2 times 3 and divide it by 2, I can go 2 routes with this. I can either multiply the top first, 2 times 3 is 6, and divide it by 2. My answer would be 3. Or I could reduce these 2's, which would become 1, and then 1 times 3 is just simply 3. So either way, I get the same answer. On this one. But how come this works and this doesn't work? I have 2 plus 3 over 2. Well, 2 plus 3 is 5. 5 over 2 is 2.5. And here, if I reduce the 2's, I end up with 1 times, or maybe 1 plus 3, which would give me 3, or maybe 4, depending on how you look at that. The main point is that those come out to be 2 different numbers. So how come you can do it in one area and not in the other? And the short answer, or the answer, is that all of these are multiplying. I have 2 times 3 divided by 2, whereas it says 2 plus 3 divided by 2. So this, whenever you have addition or subtraction, you can't simply reduce something like this. And let's just try 1 or 2 of these and let's see how they go. So the first one says simplify if possible. So what I want to do is I'm going to factor out something from the top one. If I'm looking at A, I'm noticing that both of those have an x squared in them. So I'm going to pull out that x squared. And what's left over is going to be a 6x plus 1. And this is being divided by x squared. And I notice now that I could reduce this piece and that piece. And that means my final answer would just be 6x plus 1. Now as I go over here to part B, I'm trying to do something similar. If I wrote prime factorization, this would be 2 times 3 times a plus x times x. I'm looking for something that they both have in common. They both have a 2? No. They both have a 3? No. They both have an a? Nope. Another a? Well, nope. They both have an x? No. So these do not have anything that in common that I could factor out. And then, since I can't factor something out, that means I can't reduce anything. So I'm going to just simply write in here, can't reduce. And then moving on to part C, I'm looking for things they have in common. Again, if I write that prime factorization, that would be 2 times 2 times 1, 2, 3, 4, 5 plus m times m over m squared. So looking at the top, what do they both have in common? Well, they both have a couple m's in common. So we're going to go ahead and factor that out. I'm going to have m squared times 4, because those are left over, and 1, 2, 3 m's, m cubed, plus m to the first power, or this, sorry, I don't know what just happened through my mind there. I used everything from the second part of that, so it's going to simply be a 1 to hold its place value there. And then this is all over m squared, so these m squareds will reduce. My answer is going to be 4m cubed plus 1 will be my answer on that one. Alright, and the last thing we're going to try to do today is solve these using parallel lines. So just remember, on parallel lines we have corresponding angles. If we have two lines that are parallel and cut by a transversal, this one is going to be the same as this one. This one's the same as this one. That one's the same as that one. That one's the same as that one, which also happens to be the same as this and this. So just have those nice relations, okay? So remember that, review over that if you need to. So again, we're just trying to find this piece and this piece, which we did before, whenever they told us that this angle is the same as that angle, or something like that. So we'll do the same thing here. Small triangle, big triangle. The small one is 4, 5, and 7. Big one is going to be 4 plus 3 is 7. This side down here is y, and the side over here is 5 plus x. So let's just see here. I have the 4 and the 7 in the same position. So I'm going to need to multiply. So my scale factor is equal to 7 over 4. So if I want to find, say, y, I'm going to say its corresponding side, which is 7. 7 times my scale factor, 7 over 4, is equal to my y. So now multiplying these is going to be 49 over 4 is equal to y. Okay. Now it says solve for m and n. So same idea here. We need to see if these are congruent or similar. That one's the same as that one because they are vertical angles. And since this top line here and this bottom line here are parallel, I know opposite interior angles are the same. So this one is the same as that one, or this one is the same as this one. So let's see if we can just find a scale factor. Maybe let's draw those triangles out. I'm going to flip that one around, top one around. This side over here is m, 4, 3, and the bigger one there, 6, 7, n. So let's see, I guess we'll have to compare these sides because they both have a number there. Here from smaller to larger, we're going to multiply. The scale factor would have to be 28. So let's do that. Let's say 3 times 28 over 1 is going to equal to n. That means n is equal to 84. And then I kind of have to go the other way. If I want to find this m, I have to say 6 times my scale factor, which is 7 over 4, is equal to m. This reduces. 2 goes into that 2 times, this goes into that 3 times. It's going to be 21 over 2.